Hello everyone, and welcome back to the Fluctus Channel. The B1B Lancer was built to combine three qualities that rarely appear in one bomber: heavy payload, intercontinental reach, and supersonic speed. Its long fuselage, 4 powerful engines, and variable sweep wings allow it to behave differently during each phase of flight. With the wings extended, the aircraft gains lift for takeoff and landing. When they sweep backward, drag falls and the bomber can accelerate beyond the speed of sound. The result is a machine designed to reach distant targets quickly while carrying enormous quantities of conventional weapons. Before any mission, however, the Lancer belongs to the maintainers. At Al Udeid Air Base, airmen from the 34th Aircraft Maintenance Unit worked around deployed B1Bs, opening panels, examining landing gear, servicing fluids, testing avionics, and checking the complex wing sweep mechanism. Crew chiefs walk beneath the aircraft with flashlights, searching for leaks, damaged fasteners, worn tires, or anything that could become dangerous after takeoff. Specialists inspect engines, hydraulics, flight controls, electrical systems, and defensive equipment before the bomber is released to its aircrew. The engines receive their own demanding tests. At Dyess Air Force Base, component maintenance airmen operate a hush house, an enclosed engine test cell built to hold a jet engine while it runs at high power. The engine is mounted to a test stand, connected to fuel, control, and monitoring systems, then started while technicians remain behind protective barriers. Sensors measure temperature, pressure, vibration, and thrust. The structure channels deafening exhaust away while reducing noise outside. If readings move beyond limits, the run is stopped and the engine returns for repair. Weapons preparation happens in parallel. During a joint Navy and Air Force quick strike exercise, crews built air-delivered naval mines from bomb bodies, tail assemblies, fuses, and specialized components. Technicians inspected each section, fitted the parts, secured connections, and moved the finished weapons toward the bomber. Quick strike mines can be dropped from aircraft into maritime areas, where they become underwater barriers against ships. Loading the B-1 requires patience and precision. The bomber has 3 internal weapons bays, allowing it to carry a large conventional load without external racks. Weapons are placed on trailers, rolled beneath the aircraft, raised to the correct height, and aligned with rotary launchers or bomb racks. Airmen secure suspension points, attach electrical connections, and conduct repeated inspections. One misplaced pin or loose cable could stop a weapon from releasing correctly. Once the aircraft is ready, the 4-person crew boards. Two pilots sit in front. while offensive and defensive systems officers operate stations behind them. They review mission data, start aircraft systems, confirm navigation, test communications, and monitor engine indications. Outside, maintainers remove safety pins and covers before guiding the bomber away from its parking position. At Dias, B-1s have launched with all 4 afterburners glowing. The bomber accelerates down the runway as orange flames extend behind the engines. Its wings remain forward for lift, then begin sweeping back as speed increases. The landing gear folds away, and the aircraft climbs with the force of a fighter despite its size. During bombing training, the crew follows range instructions, confirms target coordinates, and prepares the selected weapon. The offensive systems officer manages navigation and release calculations while the pilots hold the required altitude, speed, and heading. Bay doors open, weapons fall clear, and the bomber continues through the run. The B-1's power is not only the explosion below, it is the entire chain above it. Maintenance, engine testing, bomb building, loading, crew coordination, and a supersonic aircraft, delivering a heavy conventional strike with speed and accuracy. This training also teaches crews to adapt when targets move or weather changes. The B-1 can release different conventional weapons from high or low altitude, but every choice affects fuel, timing, exposure, and escape routing. On a range, controllers score accuracy and confirm that the bomber remained inside its assigned airspace. Back at base, maintainers review recorded data, inspect bays, and search for heat, vibration, or structural problems created by the sortie. Weapons teams account for every item, while aircrew members debrief what worked and what must change. The mission ends only after the aircraft, people, and records are ready for the next launch. The Lancer emerged from a long history of American bomber design. During World War II, the B-17 Flying Fortress carried large bomb loads across Europe, but it was relatively slow and depended on formation flying, defensive guns, and fighter escorts. The B-52 Stratofortress later brought intercontinental range and immense payload, yet its large radar signature and subsonic speed made it vulnerable to increasingly advanced air defenses. Cold War planners wanted a bomber that could fly faster, penetrate at low altitude, and survive by using terrain, speed, electronic countermeasures, and a smaller radar return. The original B-1A reached supersonic speed at high altitude, but the program was canceled before returning in redesigned form. The B1B entered service in the 1980s with reduced radar signature, stronger low-level performance, and variable sweep wings. It eventually shifted from a nuclear role to conventional warfare, carrying guided and unguided weapons in conflicts from the Balkans to Afghanistan and Iraq. The next transition is already underway. The B-21 Raider uses a flying wing shape and modern, low-observable technology to penetrate future defenses. Test aircraft have completed takeoffs and landings as the Air Force develops a bomber intended to perform both conventional and nuclear missions. As B-21 production grows, it is expected to take over missions now shared by aging B-1, B-2, and B-52 fleets. Although the transition will require years of testing, training, and infrastructure work. Keeping the B-1 useful until retirement has required constant upgrades and unusual maintenance solutions. One retired aircraft, nicknamed Spectre, was moved to the 76th Expeditionary Depot Maintenance Flight to become a maintenance trainer. Transporting the stripped bomber required careful preparation. When the wings were removed, technicians added counterweights so the fuselage would remain balanced and stable during movement. The aircraft could then be used to teach repair procedures without taking an operational bomber away from the flight line. The trainer helps maintainers practice difficult jobs, study hidden structures, and test repair methods before applying them to active aircraft. This matters because many original components are no longer produced in large numbers. Fabrication shops, therefore, create replacement parts from metal stock, technical drawings, measurements, and machining tools. Airmen cut, bend, drill, weld, and finish parts that keep an aircraft designed decades ago flying. The B-1 has also received cockpit and battle station improvements. The integrated battle station upgrade added modern displays, updated diagnostics, improved communications, and better situational awareness. Instead of relying on older instruments, crews gained digital systems that made information easier to share and faults easier to identify. These upgrades extend service life, but they do not erase age. Every high-speed flight, wing sweep, low-level maneuver, and heavy landing adds stress to the airframe. Maintainers inspect structural areas, repair cracks, replace worn components, and track the history of individual aircraft. The B-1 remains operational because the Air Force treats modernization and maintenance as one continuous mission. Its future may belong to the B-21, but its present still depends on thousands of people preserving a bomber that transformed speed into long-range striking power. The AC-130 gunship approaches ground attack in a completely different way. Where the B-1 races toward a target, releases weapons, and leaves, the AC-130 remains overhead. Built from the C-130 transport airframe, it carries sensors, communications equipment, fire control systems, and side-firing weapons that allow the aircraft to circle a target while keeping its guns pointed inward. Modern AC-130J Ghost Riders can employ a 30mm cannon, a 105mm howitzer, and precision-guided weapons. This mixture gives crews several levels of firepower, from rapid cannon bursts against vehicles and personnel to heavy 105mm rounds against fortified positions. Preparation begins with ammunition handling. Crews bring rounds to the aircraft, inspect them, and load them into protected storage and feed systems. The 105mm shells are handled individually because each round is large and heavy. Cannon ammunition is arranged so it can feed reliably during flight. Maintenance teams conduct digital pre-flight checks across the aircraft. They inspect engines, propellers, landing gear, hydraulic systems, sensors, defensive equipment, and the gun mounts. Inside, specialists power displays and test the network linking navigation, sensors, communications, and weapons. Every station must exchange accurate data because one crew member may detect a target while another confirms identity and a third prepares the gun. Before takeoff, pilots and mission crews review weather, airspace, threats, friendly positions, rules of engagement, and emergency procedures. The engines start one by one, propellers begin turning, and the gunship taxis like a transport aircraft carrying an entirely different purpose. Once airborne, it climbs toward the operating area and joins other aircraft when formation training is required. Inside the cockpit and battle stations, coordination drives the mission. Pilots maintain the orbit. Navigators manage position and timing. Sensor operators use infrared and electro-optical cameras to locate and track activity on the ground. Fire control specialists calculate where the aircraft, target, and weapon must align. Electronic warfare crews watch for threats, while communications operators maintain links with forces below. The gunship normally flies a left-hand orbit, placing its side-mounted weapons toward the center. As the aircraft circles, computers continually update range, angle, speed, wind, and aircraft movement. The crew verifies the target and receives clearance before firing. The 30mm cannon produces rapid bursts. The 105mm weapon delivers a much heavier strike, with the recoil felt through the aircraft. After landing, maintainers inspect the guns, clean residue, check mounts, service systems, and record ammunition expenditure. The B-1 and AC-130 represent two extremes of American air power. One uses supersonic speed, internal bomb bays, and long-range penetration. The other uses endurance, sensors, and orbiting fire support. Both depend on maintainers, weapons specialists, and crews who turn complicated aircraft into coordinated combat systems. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.